Okay, this is the solutions video to Physics Chapter 2, Extra Practice Problems 6 through 10. Here are 3 equations from this chapter, and let's get into number 6. So number 6 says a cheetah accelerates in a straight line from a velocity of 10 meters a second to 15.2 meters a second in 2.1 seconds. How much distance was covered during this acceleration? All right, we're wanting to know delta x, the displacement. We know initial velocity is 10. Final velocity is 15.2. And time is 2.1 seconds. Okay, we're going to end up using, if we want to know delta x and we have time also involved, we're going to use equation 3. So delta x is equal to initial velocity, 10 meters a second, times time, 2.1 seconds, plus 1/2. And we are trying to get... Oh, in this case, yeah, this is going to be a two-parter. So I've got 2 variables here. But I have enough information since I have the time and initial velocity and final velocity to get acceleration through using equation 1. So we'll come back to this in a second. So if we use equation 1, we have the final velocity, 15.2 meters a second, is equal to the initial velocity, 10 meters a second, plus acceleration times time, 2.1 seconds. All right, so subtract 10 from both sides and solve for acceleration, and you'd have 5.2 meters per second over 2.1 seconds. So acceleration is going to be 2.48 meters per second squared. So sometimes you have to use 2 different equations. Now we can get delta x. So that's going to be 10 meters per second times 2.1 seconds plus 1/2 times 2.48 meters per second squared times 2.1 seconds. Don't forget to square it. All right, if you put all that in your calculator and things don't go wrong, you'll end up, this section is 21. This section is 5.47. And so that is going to be 26.47 meters. All right, cool. So that's one we haven't had to do one quite like that yet, where you had to do 2 different equations. But that's a good problem. Good problem to study for the test. All right, number 7. Number 7 says, upon discovering a hole in the ground, a girl drops a rock and times how long it takes for the rock to hit bottom. Neglecting air resistance and the time for sound to travel, how deep is the hole if it takes 5.3 seconds for the rock to hit bottom? All right, let's write out what we know. So this is a free fall problem. And, we don't know if we're in meters or we're in feet. I'm going to go ahead and solve it in meters. On the test, that won't be an issue. I'll tell you what to do. So acceleration is negative 9.8 meters per second squared. Time is 5.3 seconds. We want to know how deep is the hole. So what variable are we solving for? I'll give you a second to answer it. All right, displacement. That'll tell us how deep the hole is. Okay, we've got acceleration, we've got time, we want to know displacement. What do we know about initial velocity? All right, the girl just drops the rock. She didn't throw it down, so it's going to be 0. So we're going to use equation 3. Delta x is equal to v naught t plus 1/2 a t squared. This portion of the equation is 0 because initial velocity is 0. So delta x is going to be 1/2 times negative 9.8 times 5.3 seconds. That's a deep hole. Don't forget to square it. So 1/2 times negative 9.8 times 5.3 squared is, you'll get negative 137.6 meters. Well, we don't usually report the depth of something that way, so we would report it as 137.6 meters, or if you did this in feet, I got an answer for you. It's 449 feet. So in this case, either one is fine because the problem didn't specify. All right, I think number 8 and number 9 are related, so I'm going to go ahead and erase and put those together on the board. So they use some of the same information. All right, number 8 says, neglecting air resistance, what would be the final velocity of a sandbag that's dropped from a hot air balloon at 1,140 feet? Okay, so number 8, displacement is equal to negative 1,140 feet. All right, it's being dropped down, so it's negative. Acceleration, we're in feet, so negative 32 feet per second squared. We want to know final velocity. We don't know anything about time, so I think we're going to need equation 2. So we'd have final velocity squared is equal to initial velocity squared. Now, what is initial velocity? Is the sandbag thrown down? No, so it's 0. So I would have 0 squared plus 2 times negative 32 feet per second squared times delta x, negative 1,140 feet. Those two negatives are going to cancel out, and I can get a positive number that I can take a square root of. All right, so v squared is 72,960 feet squared per second squared. So final velocity is going to be the square root of that, which is 270.11 feet per second. But something is wrong with this answer. What's wrong with it? Well, it's a negative 270.11. Why is it negative? Because the sandbag is going down. This particular problem, this particular equation, you have to kind of use your noodle, because you're always going to get a positive answer when you square something or take the square root of something. So we have to use our physics knowledge in order to get the right answer. And that negative is more than just 1 point off on a test. You got to understand that. All right, let's do number 9. I'm going to leave the same information up. This time we have a little bit of an initial velocity. The initial velocity in number 9 is if it were descending at a rate of 250 feet per minute. So that'd be negative 250 feet per minute. All right, so feet per minute, feet per second squared. I'm going to have to do a little bit of a unit change here. Excuse me just a second, I gotta get a drink. Right, I need a cough button on this iPad. Oh, so sorry about that. Okay, I need the time to be in seconds. So put seconds on bottom, minutes on top. One goes by the bigger one. 60 seconds in a minute. So negative 250 divided by 60 is going to be negative 4.17 feet per second. So it's not descending very fast. All right, the balloon is descending, but it's not really descending very fast. So we shouldn't expect a big change in this. So we're going to use the same equation, same type of problem. Final velocity squared is equal to the initial velocity, negative 4.17 feet per second. Square that. Plus 2 times negative 32 times delta x, which is negative 1,140 feet. All right, so that's going to give you a velocity squared of 72,977. So if you take the square root of that, velocity is 270.14 feet per second. But what have I not done to complete this? All right, it needs a negative, just like in the last one. We're going down. All right, don't make that mistake on the test. Make sure you think about what you're. Don't just put the numbers in your calculator, but think about what you're solving for. Think about the situation. All right, number 10, I'm going to solve this one in two different ways. The first time, I'm not going to use the quadratic formula. The second time, I am going to use the quadratic formula. Okay, so number 10 says a skyscraper, the Exceed 4000, has been proposed to be built in Tokyo, Japan. Was it ever built? I have no idea. This book is almost 20 years old. It's over 20 years old, so maybe it was built. It will have an estimated height of 4,000 meters. If a coin was thrown upward, by the way, that is a huge building. That is, let's see, that's 2.5 plus miles tall. So, oh my gosh. If a coin was thrown upward from the edge of this tower with a velocity of 200 meters a second, how long will it take for the coin to reach the ground? We're going to neglect air resistance. Okay, let's write out what we know. So we want to know how long will it take to reach the ground. So time. We know acceleration is negative 9.8 meters per second squared. Okay, we know that delta x is negative 4,000 meters, not 4,000, negative 4,000. And we have an initial velocity of, it's thrown upward at 200 meters per second. All right, now if we were to put this into equation 3, we would have to use the quadratic formula. And I'm going to go ahead and do that in just a little bit. But let's say you don't like the quadratic formula. We could solve for the final velocity using equation number 2 and then plug that into equation number 1 and solve for time. So let's try that. So final velocity is equal to the initial velocity plus 2 times negative 9.8 times negative 4,000. All right, so I'm going to have to get my calculator real quick here, if you'll just bear with me a second. All right, so that's going to be 200 squared plus 2 times negative 9.8 times negative 4,000. All right, it's 118,400. meters squared per second squared. So if we take the square root of that, right, so I like to raise that to the 0.5 power. It's faster a lot of times. That's 344.09 meters a second. So that's the velocity of right before it hits the ground. But we know it's got to be negative because it's going down. Now we can get time by using equation 1. So here we used equation 2. We can get time by equation 1 because we have the final velocity is equal to the initial velocity plus acceleration times time. So I've got negative 344.09 meters per second is equal to 200 meters per second plus negative 9.8 meters per second squared times time. All right, so if I subtract 200 from both sides and then divide by negative 9.8, we know that time is going to be negative 544.09 divided by negative 9.8. All right, you put that in your calculator to get 55.5 seconds. All right, so a really tall building, so it takes a long time for that coin to hit the ground. Now let's say you didn't want to go through all that. 2 equations, that's too much for you. You want to just get it done all in one equation. All right, we're going to have to use the quadratic formula, so let's go through that. And on the test, it's up to you if I give you a problem like this, whether or not you use the quadratic formula or just try to do it by using 2 different equations. So remember, I shouldn't have erased all that, but and again, delta x is equal to negative 4,000. The initial velocity is equal to 200. And acceleration is negative 9.8. And then time, we don't know. All right, let's plug it into equation 3. I would have negative 4,000 is equal to 200 times time plus 1/2 times negative 9.8 times time squared. So that's a quadratic equation. Now I'm going to get rid of the units to make everything a little bit easier here, and you have to set it equal to 0. So if I have negative 4,000 equals 200t minus 4.9, because 1/2 times negative 9.8 would be 4.9 t squared. Let's move all this to the left, and I'd have 4.9 t squared minus 200t minus 4,000 equals 0. Remember, the quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. Right, so a is 4.9, b is negative 200, c is negative 4,000. So I'd have negative 200, so that's 200 plus or minus the square root of negative 200 squared minus 4 times 4.9 times negative 4,000 all over 2 times 4.9. All right, if you put that all in your calculator correct, you're going to get 2 answers, 55.5 seconds, and you're going to get negative 14.7 seconds. What do we call the you can't have negative time, so what do we call the negative 14.7 seconds? Do you remember the term? It's extraneous. So you'll get an extraneous solution a lot of times using the quadratic equation. Not always, a lot of times. So you get that same answer of 55.5 seconds. So whichever way you want to do it is fine with me. I think the safer way is probably to avoid the quadratic formula, but be my guest. So that is it for the extra practice problems, let's talk about a test review here real quick. So this chapter honestly has very little vocab. It's almost all math. So if you were not going to read a chapter, this would be the one to do. All right. So it has very little vocab. There's a little bit. I can't say there's no multiple choice or true false, but there's a very little vocab. You have to know the 3 equations. What I would do is rework the practice problems and go over the review questions again, just in case. And if you have the time and you miss some of them, rework the extra practice problems that gave you trouble, if any. All right, this test has a pretty high average. I think it's somewhere around, it's in the high 80s or low 90s. So a lot of people do well on this test, and I think this is an enjoyable chapter. So good luck on the test, and I will talk to you on the chapter 3, lecture number 1.